Today we're going to review ELR 3.4, which is all about acceleration. So in order to understand this ELR, you're going to need to know that acceleration is speeding up or slowing down. You'll also need to know that deceleration, I think that has two C's, is simply slowing down, so it's a negative acceleration. You'll also need to know that delta, so that triangle, is a change in blank. So whatever follows delta. You're going to need to know that for the equation for acceleration. And finally, you're going to need to know velocity, which is basically overall speed. The equation for acceleration is A, acceleration, equals change in velocity over change in time. So delta velocity over delta time. And that is basically the final velocity minus the initial velocity. And then final time over minus the initial time. So some scenarios or examples. Someone accelerates from 3 meters per second to 11 meters per second in 5 seconds. So using our equation, acceleration in this scenario would be final velocity, which is 11, minus initial velocity, which is 3, then final time, which is 5, minus initial velocity, which is 0, because he starts at 0 seconds. The timer starts. And that equals 8 over 5, which is 1.6. And then units for acceleration are meters per second or meters per second squared. Another example for a slightly different scenario. An object goes from rest to 9 meters per second in 15 seconds. So in order to calculate acceleration, just enter everything into our equation. A equals the change in velocity, so final minus initial, which is 0 because it starts not moving at rest, 0 meters per second, over final 15 seconds minus 0 initial seconds. And that is 9 over 15, which is 3 over 5, and that equals 0.6 meters per second squared. Of course, never forget your units. One more example for a slightly different scenario. An object decelerating. So it goes from 9 meters per second, let's say, to 2 meters per second. So it's decelerating, it's slowing down. And it does that in 4 seconds. Entering our equation, acceleration equals final minus initial over final minus initial, and that is -7 over 4, which is -1.75 meters per second squared. And since that is a negative acceleration, that means it's decelerating. It's a deceleration. So now for some apply questions. For apply question number 1, an object accelerates from 4 meters per second to 31 meters per second in 9 seconds. What is its acceleration? So pause the video and calculate its acceleration. Okay, by now you've calculated the acceleration, and the answer is acceleration, A, use the equation, equals final velocity minus initial velocity, so the change in velocity over final time, minus the initial time, so the change in time, which equals 27 over 9, which is 3, and then units, meters per second squared. Now for the second applied question, I'm going to get out another sheet of paper. A man starts a race at rest, so he's starting behind the finish line, or behind the starting line, and he finishes the race in 30 seconds. I'm just writing down the important information. And at the end of the race, his velocity is 14 meters per second. So since he starts at rest, he's at 0 meters per second at rest to 14 meters per second in 30 seconds. What is his acceleration? So pause the video, calculate his acceleration. By now you've calculated it. Use the equation A equals change in velocity, which